today we are going to learn about electronic configuration of ions. So we are still on the same topic of electronic configuration of atoms, but today we can see that there are two types of electronic configuration. There is one that we had been covered previously in the previous lessons, which was electronic configuration of neutral atom. So today we are going to see the difference between a neutral atom and ionized atom. So when an atom is neutral, it means that it is still having its original number of electrons. If it has lost one or more than one, depending on its valence, it becomes ion. And also, if it receives more electrons than its original electrons, it becomes ion. So, which means it is ion. It is a disturbed atom or an atom in a disturbance. That's what I can say. And so we are going to see the difference between ions and the stable atoms or neutral atoms. You know that the neutral atoms, their atomic number is always equal to the number of electrons, which means it has not lost anything. It has not lost any electron, or it had not received or gained any electron, any extra electron. If it receives, it becomes ions. It becomes charged, electrically charged. So to be electrically charged, it means one can have a positive and another one can have negative. We are going to see how to find if an atom is going to become a positive ion or a negative ion. First of all, let us see what is ion. Let us try to write here. So ion is an atom or a group of atoms bearing an electrical charges. So ion is an atom or a group of atoms bearing an electrical charge. So what does it mean? It's all about electrical charge. Electrical charge, we have positive and negative and negative. So when it is positive here, and there is another one which is negative, which means they can electrically attract each other, or they can make electrons move. They will move. One will attract each other, and when one is on this end and another one is on this end, and this positive will attract the negative, and in this attraction, they traveling from one point to another point where negative is coming to search for the positive. Here we shall get electricity. The movement of electrons always they produce electricity. That's why we call it electrical charge. Because if one can be charged positively, and this one can be negative, and this one can be charged positive, this means that here the positive the positive and negative, they attract each other to produce electricity because electricity comes from the movement of electrons. So that's what I can tell you about the charges. And then here, because we have in previous lessons, we studied about how to find if an atom is metallic or non-metallic. We are trying to draw a periodic table showing which part is metals and which part is non-metals. Let's see here. For example, I can try to draw the periodic table here as we. So this is enough. This is going to be enough to demonstrate our experiment here. So here, I told you that from family 1 up to family 3, 1, 2, 3, up to here, and you come to the left side, they are all metal, they are all metals. And then from third or fourth to the right side, they are all non-metal elements or atoms, non-metal elements. So, as you can see, for example, I can pick randomly, like a lithium. It is a metal because it is found in a left side of boron, starting from boron. Even boron, it belongs here because it is in group 3. But if we say carbon here, it is in non-metals because it is in fourth group or family, and from fourth group to the right side, or they are considered as non-metals. So from here, I can tell you that these metals, we call them donors. And this one, we call them receivers. So the donors and the receivers, donors, they are metals. Receivers, they are non-metals. So the donors, they are ones which are positively charged it is in terms of ions. The ions of metals, they are positively charged always. The ions of metals, they are positively charged always. So here you will catch these three things. From family 3 to the left, they are metals and they are donors. When they become ion, they are positively charged. And then from family 4, from fourth family up to eighth family, or from fourth family to the right side, all of them they are non-metals, which means they are receivers. All receivers they always get charged with those negative charges, so they are negatively charged. So as a beginner, you start with this. Know that you have to first know how to identify a non-metal in the periodic table, and how to identify a metal in a periodic table. Then after, you have to know that the metals, if they are becoming ions, they become positive. And non-metals, if they become ions, they become negative. So that's the basic that I can tell you right now. And then even if I remove this, okay, I want to show you the exercises, how to find if an atom or an element is metal or non-metal. I think we are together now. So we say that there we have positive ions and negative ions. These positive and negative ions, the positive ions, we call them cation. And the negative ions, we call them anion. All anions, cations, anions. If an atom is electrically charged positively, it is called the cation. And if an atom is electrically charged negative, it is called anion. So step by step, you follow step by step. These are just the names, and you have seen how to find out if an atom is electrically charged positively or negatively. But the cations, for the cations and anions, sometimes because we say that metals they will be called cations, and also the non-metals they will be called anions when they become ions. But there is something, not here a group of atoms, because we said ion is an atom or a group. So we were talking all about the atom or a group. It did not touch on this. We are going to see how a group or the characteristics of group of atoms becoming electrically charged. So it means it can be a cation when it is a group of ions. It can be a cation even if it doesn't have any metal containing that group. I give you one example, but I can give you like ammonium ion, for example. Let me give you ammonium. Ammonium ion, it has positive here. They are special. These ones, they are special. They are known. We shall see when we reach in another chapter. They are known that this one, it is positively charged. But if we say, for example, this is the nitrogen, this is hydrogen, and you remember that hydrogen sometimes can behave as an metal and sometimes can behave as a metal. Which means even if you take hydrogen as a metal, this can be a mixture of metal and inanimate. But here also it worked here as a halogen because the combination of nitrogen and the hydrogen to become this ion of ammonium, it is not ionic. I can say that it is not ionic, but it is the more covalent than to say that it is ionic. But this ion, when it is combined with another ionic metal, it can become ionic compound. So we shall see. We shall explain this. And then here, let us see here. This is the. Let us see like this. This one is what we call permanganate. Permanganate. This is the manganese. Manganese, it is a metal. It is a strong metal, which is the a variable valence metal. It is all we can say transition metal. Manganese, it is a transition metal, and here it is combined with hydrogen to produce a negative ion, which is the anion. So when we reach on in terms of groups of atoms bearing an electric charges, they can be the mixture of metals and non-metals to produce cation or produce anion. So which means all we explained before, they were all about single atoms. Single atoms, we call them monatoms. Monatoms, it is as we say the single atoms. When an atom it is single. For example, magnesium, it is single. For another example, like chlorine, it is single. For example, we can say hydrogen. Also, it is single. It is one type of atom. These we call them monoatoms. If they become ion, it is monoatom and atom ions. They are ones when they are metals, they will become positive, and when they are non-metals, they will become negative. So I don't know if you are with me now to know these simple differences, how to identify if an atom, the type of ion of an atom or of a group of atoms. I have said that a group of atoms, it is contradicting the law of saying that the metals they will be charged positive and the non-metals they will be charged positively. So because the combination of metal and the non-metal, they can produce positive or negative ion. So make sure these ones we can call them special. They are special ions. When you are studying chemistry, you have to memorize these special ones. You have to memorize them to make sure you will understand chemistry very well. For example, this one, it's not easy to prove how it is charged negatively, but it is proven that this is a permanganate ion, which is anion, and this is the ammonium ion, which is the cation. Are we together? So let us continue if you have understood. So whenever you have any question or something to ask, you can ask about the topic, and then after I will be After I will be explaining you. So I can. So as we continue, we are going to see how to note the ions or the notation of ions and how to write them in a different way from the way we write the atoms or the symbols of atoms. So it means that we are going to see how to know when you are reading like books and so on, how to know if an atom is iron or not iron. So as we continue here, iron notation is that we can say this is a neutral atom and the ionized atom. We are in notation. We are in notation here. So, for example, here we have magnesium. Magnesium, here it is neutral, or I can say it is stable. Magnesium here, it is stable. Here we have also aluminium. Even when we write like this, aluminium here also is stable. It means that it did not it did not lose anything and did not receive anything. But when it is ionized, it become iron. Iron. Magnesium, it become like this. Positive. And aluminium, it become also, I can put here, aluminium also, it will become also positive. Why? Why magnesium is becoming positive? And why also aluminium is also becoming positive? Let us see another example. Let us see chloride. Or we can say, let us see nitrogen. Here, the nitrogen, the neutral atom, it means chloride and nitrogen. They are in a stable state. They did not lose any electron and they did not receive anything, which means they are in their normal state or in their natural state. That's why we call it the neutral atom. It's neutral. It doesn't have any charge or any load. It is not loaded or it did not lose anything. But when we come on side of the ionized atoms, chloride it will have minus, and nitrogen it will have minus. Why? So if you follow this lesson, you can identify why we are putting positive here, positive here, positive here, negative here, and negative here. Think about it. So, but let me answer the question. If you have thought about it and you feel like you have the answer, let us go together. Even if you don't have, I can tell you that magnesium in the periodic table it belongs in metal side, where the metal side in the periodic table it is from boron, which is in the third family up to the left of the periodic table, and then also the chlorine. For example, chlorine it is in left side, in the right side from carbon. The carbon it is one which is in fourth. When you start from the fourth family and you continue to the right side of the periodic table, it means that they are non-metals. They will be having negative. That's the answer. But we also have to know, we have saw the type of ion. Here, we have seen that this one, it is called cation. Then this one is cation because it has positive. Then here, it is called anion because it has negative. And here also, it is the anion because it has negative. But positive, which means this one we have noted as it has one positive, and this one also has one positive, and this one negative, and this one negative. This is not the end of this exercise. We still have to add more. Because we have to know the number of charges here. The number of of charges. How do we know the number of charges? How do we know the number of charges? If you ever seen the previous lesson of electron valence, you can answer this one. The number of charges of each atom here, of each ion here, it is going to be equal to the number of valence, of electron valence that it has naturally. Are we together? The number of charges here, it is going to be equal to the number of electron valence of each atom. For example, I give you, let us go back in that lesson. Still, I will draw the periodic table here, small, B, C, let me try to fit it here, like this, and make sure it fits. All right. Uh-huh. So, in electron valence, we say that here it is family 1, and this is family 2, 3, 4, 5, 6, 7, and 8. And here we say that it has one valence. You remember, I will repeat this exercise because we have them in the previous lessons. Let us continue. Here it has valence 2. Here it has valence 3. And also, as you can see, 3. And here it has valence 4. And here it has valence 1, 2, 3. And the lone pair here. And here it has 1, 2, 3, 4, 5 lone valence, and this one, another lone valence. So you studied this in previous lesson. And here it has lone pair, lone pair, lone pair, and one valence, one electron valence. And here they have lone pairs only, they don't have any valence. The valence electron of this family of noble gases, it's 0. It has all the lone pairs, which are not considered as electron valence. Its electron valence is 0. Here, electron valence of this family, including hydrogen, lithium, sodium, potassium, it is just 1. If this one becomes iron, it will indicate with 1. And this one, this family, beryllium, magnesium, calcium, and so on, down here, they have two electron valence, which means if they are going to become ions, they will have the number of charges equals to this valence. And here, boron, aluminium, and so on, germanium, and so on. Also, it will have 1, 2, 3. 1, 2, 3. They will have 3 number of charges. Because we have learned how to find if it will be positive and if it will be negative. You can put that sign aside after knowing that is going to be charged positive or negative. And then after you come here in knowing the electron valence number of each of that atom. After finding them, you come and write it in this side. For example, now, because magnesium it is falling in family which has 2 electron valence, which means it will be positive and it will be positive 2. And aluminium, it will be positive, and aluminium has fallen here 1, 2, 3. It will be in a family of 3 electron valence. It will be positive 3 positive. We call it 3 positive, not positive 3. Don't write like this. When you are writing about the charges, don't write like this. This means another. It means it has another meaning because this is the oxidation state. It is called the oxidation state. Oxidation state, it is where we start with positive here and we end with the number. So these are it's like they are like the concepts. you have to start with a number if you are writing about the number of charges. If you're writing about iron, so if you are writing about the oxidation state, I think we will not cover that. We will cover it next time. It's when you start with the sign and then you end up with the number. So which means where we are now, this is not true. The correct one, it is this one. So here we have seen that chlorine will have negative because it falls metals and non-metals. These are the receivers and these are the receivers and these are the donors. Have you seen? Which means this will be having a positive charge and this will be having negative charges. So and this which has negative charges include all of these. One of these, each of these will be having negative. But here you will exclude it is to this level. You will exclude this family, which means it is from this up to here. You make sure you remove this because you have seen that it doesn't have any electron valence number. So we exclude it because it doesn't have ions in normal state. So and as you have seen, so chlorine is here. Chlorine is here. As you see, chlorine here, they are only pairs. It has one valence. So if it has one valence here, for example, which means here also it will be one. We don't write one. We leave it. Yeah. So if you write it here, it's okay. It's okay. They will mark you. But it's not necessary. You don't put it here. Just you put chlorine minus. So and here we have also nitrogen. We have seen that nitrogen defaults in receivers, which is here on this side, and we see that nitrogen will be having 1, 2, 3, and one lone pair, which means electron valence. Then the single electrons in outermost shell, they are 3, which means it will be having the number of charge. It will be 3. The negative, it means it is an metal. So as you continue, you will be understanding where how to write these things correctly, because many students they mix it, like they write it like this, like -3, like this. So this is not iron. This is you have indicated like an oxidation state, which may not match and may be different from what they have asked for. So continuing, by continuing, let us see another one. By continuing, let us see how to do electron configuration of them. Electron configuration. Make sure you have noted how to write them down correctly. This is long. It means it will be negative. It will be 3 negative. So electron configuration of iron or ions. So here, configuration. This is a neutral atom, and this is ionized atom. Let us start with the example that we had here. We were having magnesium, for example, when it was neutral. So here, let us have it as an ion. So 2 positive. Well, we learned all about the electron configuration of magnesium when it is neutral, because magnesium is always have 12. It has 12 electrons. 12 electrons. And its electron configuration, it's like this. 2 on the first shell. Here it is 1, 2, 3, 4. Here there are 6, 7, 8, 9, 10. And this shell also, it is full. It is full. And here we have the remaining two. The remaining two. This is the 2, 8, and the 2. This is the electronic configuration of neutral magnesium atom. So here, positive 2. What? Take this 2 positive and compare with the name donor. Two positives, which means donated, given. It has lost. Magnesium has lost 2 electrons. Metals, they are the losers, the donors. They give out. They give. It has given. It has donated 2 electrons. The remaining is at the original. It has originally it has 12. Here it has donated the 2 electrons, which means it has remained with 10 electrons. 10 electrons. They are the remaining. I don't know if you are understanding here, because this is the key of knowing the difference between the neutral atom and ion or ionized atom. You make sure if it has positive, it has lost. The positive sign, it means that its strength had been added to 2 electrons which had been lost. For example, if you have like this one, this box, it was holding 100 chokes, and now I have removed like 20, which means if this one were having 100 chokes and I have removed 20 chokes, now it's remaining with 80 chokes. So here we can say if this one it was like a box, this box, because it has lost this, it has positive 20. I can say it has positive 20 because positive 20, it has the strength to hold another 20 chokes that had been removed here. But you cannot say maybe I will bring 25 chokes, because you see the fitness of them here. It's how they are arranged here. If you bring 25 to pack them here, it will not hold them, which means it will hold only 20 because it is made to hold 20 pieces of chalk. Which means if you bring 30, it will not be able to hold. That's why magnesium has given 2, which means it has remained with the strength, or it has remained with the ability to receive back, and it's lost the 2 electrons. This is the strength. For example, here, this was a box. Let us see. If this box it is full, for example, if this box it was full of 100 chalks, let us bring more chalks here, and we try to do like this. We try to fit like this, fitting like this, to make sure it will hold. To make sure it will hold like 130. 130. It means for the 100 it can hold, you have added another 10. You have added another 10 chokes. If you have added another 10 chokes, its strength to hold 100 chokes, it had been reduced. That's why it must have negative. It's all about the strength. Because it has hold more than what it is supposed to hold. I am explaining why they put negative, and here they put in positive. For the positive, it is in need of the electrons that had been lost. But for the negative, it is very weak. It is loaded. And this load had caused this atom to be weak. The weakness is all about the negative. its strength had been reduced to, if it had been reduced, for example, here you have packed this box, and some boxes here, and it has space. For example, if it has space, these ones, it will be easier when you are making like this, maybe to pour down. This which holds many, it is very easy for them to fall down. But this one which has the one which even can be covered like this, it is not easy to make them fall down. But if they are like this, and this cover even cannot fit here, which means it is very easy. It is very easy to move it out, which means the one which holds many, it will be weak. That's why even always the positive stands here, and the negative will be coming towards the positive. Always positive, it is always fixed, even if you go in electricity. The positive cable, it is always empty. It has no electricity. If you connect it to the negative carries the extra electrons, and they come towards to be charged, to be connecting with the positive, and then the electricity will be produced. So, for that concept, you have to understand that when it is negative, it means that it is loaded. It has received many, and it become weak, and it is very tender. It can move easily. It can give again or give out easily because it is loaded. But for these which are positives, they lack something. They are positive. They have too much power to receive again the lost electrons. That's one. So for here, electronic configuration of this, electronic configuration of magnesium, when it has remained with 10 electrons, it will be like this: 2, 1, 2, 3, 4, 5, 6, 7, and 8. 8 plus 2, it is equal to 10, which is 2 and 8. This is the electronic configuration of magnesium ion. It is called the magnesium ion. It is its name. For the ions of metals, we call its name, its atomic name, and then we add the word ion. But for the nanometals, we do some modification. For example, it is chloride. You say chloride. If I say chloride, it means that it is a chlorine ion. But because it is a nanometal, we say chlorine. We shall see this in nomenclature. Chlorine, when it is ion, it becomes chloride, which means we remove this part and we put the word I like this. But for the magnesium, we just add the word ion, magnesium ion. But chloride ion, it is chloride. It is called chloride. We shall see this when we start to name the chemistry. So it is also a big chapter that we shall see after knowing this. We shall see how to name chemistry in the next chapter. So here, as you can see, this is the electronic configuration. This is equal to the neon. It is always equal to the neon electronic configuration. You can go and do exercise of neon electronic configuration. So another example, we have seen magnesium. Another example is going to be another example we have seen here. We were talking about chlorine. Chlorine, it has in its neutral state, it has 17 electrons. And when it is iron, when it has iron, who can guess? If you can guess, you can see that it has received how many? It has received the electrons equals to its electron valence, which means it has received 1. It means here it will have 17 plus 1. It has received, it is in receivers. It has received 1 electron valence. With here it will make 18 electrons. 18 electrons. So electron configuration here, for example, here it will be 1, 2, 3, 4, 5, 6, 7, 8. These are 10, 11, 12, 13, 14, 15, 16, and 17. 17. Here we have remained with 1. As you can see, its electron valence. It is always equal to this when it is neutral. And here it is electron configuration of 18. These are 2, 1, 2, 3. You know that when we are doing electron configuration using this method, we have to first fill a lone pair here in the first shell and the second shell, and above above all other shells, we first fill the 4 corners: north, east, south, and west. And when we still have electrons to add, you will do like this: 1, 2, 3, and 4. Here they are in total of 10, and we add another shell because we are doing for 18. We are making electron configuration of 18. Here 1, 2, 3, 4. Now there are 14. We are going to 18, 15, 16, 17, and 18. Here it is full. This is what we call octet rule. Octet rule is like, say, you feel when the outermost shell it is 8, it is full, or 8 electrons. We call it octet rule. So we call it octet rule. We shall see it in its lesson. It's not all about here, but you ever heard about this word octet. It means it is 8 electrons in outermost shell, which means its outermost shell it is full with lone pairs. It can't accept any other. When it is the outermost, it means it has no valence electron. This here it is 2, 8, 8. It is 2, 8, and 8. This is 10 and 18. This is the electronic configuration of chlorine. So you can do nitrogen, you can do aluminum, you can do sodium, you can do your exercise when it is ionized and when it is neutral. As it is shown here. You can do your simple you can do your simple exercise by giving yourself the examples here: nitrogen, sodium, aluminum. You can go to carbon, you can pick sulfur, you can pick oxygen, you can pick beryllium, calcium. So that's how you can be able to understand well this lesson. And if you have a question, yeah, you're welcome. You can ask. So this is how we do electronic configuration of this. I give you one more. Don't know, let me guess that maybe we can do like nitrogen. Others you shall do it by yourself. Let us see nitrogen. When nitrogen is here, nitrogen will be negative, and it is -3. And nitrogen here it is number 7. Number 7. It has 7 electrons, and here it will have equal to the 7 electrons minus or plus 3, because it will be added by 3. Here it will become 10 electrons. So 10 electrons. And here, when we do electronic configuration, it is like this. Here there are 7, 2, 3, 4, 5, 6, and 7. It has 3 electron valence. And here they became 10. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it has become new one. Here it will be 2 and 1, 2, 3, 4, 5. 2 and 5. And here it will be 2 and 8 and 8. This is a simple example. So I know that when you run using these methods that I'm using, they are basic. For the beginners. They are very easy to catch. And when you understand this, it will help you to understand chemistry generally. We are still having many lessons in this fundamental chemistry, but you make sure you run one lesson to another. So if you have any question, always I say send me a message or comment on this lesson, or you can send me WhatsApp. Yeah, but also I call you to subscribe and invite your friends also to subscribe on this channel. Thank you so much.